Okay, I just wrote a whole bunch of code. You can see here there's 245 lines. I thought about breaking them up. Like if I was writing code for an actual project, these all would have been, like I would have architected this code much cleaner, but since it's just for illustration purposes, I figured I'd write it all in one line. That makes it easier for us to just kind of navigate and see what's going on here. So what I did here is, as I said earlier, there's a page in the documentation, the multi-index documentation, that kind of goes through all of the STL containers and shows you how you would do the same container in a multi-index. So I started out and I just took the set. You can see here in the main function I have these driver functions where I'm comparing each different STL data structure and then its corresponding multi-index. So I started with the set. Obviously that one's going to be the easiest one, as we saw originally with our employees. The multi-index container acts almost exactly like a set. You can see here I'm using the default instantiation. Very simple. Same thing here with the set. I've got the employee multi-index. I'm pulling in the ID index much the same way. It's keyed based on ID, and so here I'm just inserting. You can actually treat it exactly like the set. So the multi-index gets inserted, the set gets inserted, and then when we print each, I have this little for each where I'm just printing out each employee in the set to prove that they are in fact the same. I've got this commented out, so if we run it, we should see the two values printed out exactly the same, which proves that, you know, the standard instantiation of the multi-index acts exactly like the STL data structure, and in fact it does. Maybe I should slow down because I used the same contents, so if we step through this one exactly, you know, verbatim, you'll be able to see, okay, he's just doing the same thing over and over and over again. Again, like I said, I would have kind of written a driver program for this if I really cared about code cleanliness. So all I'm doing here is I'm just inserting these employees into the multi-index, the exact same ones we were dealing with previously, because they show a couple of different interesting use cases. In this case, we've inserted bod twice with the same values, you know, blah blah blah, same thing over and over again. I did that for both cases for the employee set. Oh, sorry, this is the multi-set case we're looking at, but technically it's the same thing. The only difference here is, like, in each function I instantiated a different standard template library data structure and then instantiated a different version of the multi-index. I started with the set because it's the easiest multi-index definition, but I'm doing the same thing in every case. I'm inserting the same employees the exact same way every time and then printing out what's in the multi-index down here at the bottom and then printing out what's in whatever STL that I'm STL data structure that I'm testing against, essentially, to prove that they're the same thing. So you can see here, very simple example. It's just really proving out the use cases for each set. I did the same thing here for the multi-set. The multi-set allows duplicates. So in this case, we're allowing the duplicate indexes in when we, different IDs are not, unique IDs are not enforced in a multi-index, essentially. And as we saw previously in the original employee example, this is how you do it. You give it the ordered non-unique and pass in the ID, so that allows you to have non-unique IDs while you're inserting into the set. I print out the same thing here again. We can go down and I could uncomment it and show you, but I guess just take my word for it. I'll probably upload this code to GitHub as well, so you can play around with it and really investigate it yourself as well. After I did the multi-set, I decided to do the list, and here you can see I'm indexing by sequenced, which makes it act like a list. And here we're inserting again exactly the same employees with the same exact constructors. The difference being, obviously, these are going to be, they're not going to be ordered based on ID here. They're going to be ordered based on how we're inserting them into the list. Another thing to note is up here where we're using the insert function or method, API call, whatever you want to call it, for the multi-index. Down here it gets treated like a list if you use the sequenced index. So here it's a pushback rather than an insert. And similarly here for the STL list, it's very much the same way. After I tested the list, I went down and, so this is when things start to get very interesting, because while I was writing smart contracts, I often wanted to reach for a map, and the EOS multi-index supplies you a way of doing like primary and secondary indices. So just bear with me now, because this, you know, may or may not be helpful. It's just more of a deep dive into the multi-index. So if you want to mimic the functionality of the standard template library map, as you can see here, I've defined this employee map, and what I wanted to do here was have a map. It's kind of a useful paradigm, or a useless example, but it was kind of the easiest one to come up with respect to the employees we've been dealing with this whole time. So I wanted to map IDs, in this case Bob, to his employee version of himself. So in that case, the int 1 would map to the employee Bob, 2 would map to Susan, etc., etc. Fairly straightforward case. However, making this work for a multi-index is non-trivial. What you have to do is you have to define this mutable pair, because the second pair in an STL map, the second value in the key value pair, can actually be mutated in the STL data structure. So in order to mimic this, you have to create this struct and use this in the multi-index definition. So you can see here I'm doing this type def of the mutable pair. I called it the ID employee pair because that's what I'm trying to match as an integer to an employee, similar to the employee map. And then this is how you define the the map version of a multi-index. You take this pair, you pass in the pair type, and then give it the first, and that will allow you to key on the first value of the ID employee pair. From here, I had to create a bunch of these ID employee pairs. This was the only way I could get it to work when I was inserting into the pair. I tried, you know, various different. Up here, you can see I did this very succinct syntax where all I had to do was pass in like the curly braces, and that could reference back and know exactly what it would look back into the employee struct and go, oh, I know how to create that based on this. But for whatever reason, this mutable pair object, it was not taking it. So I created 6 of the employees in the exact same way as before, and then this is how you insert them into the map. And in this, now you can do a gets into the multi-index and all that other stuff, similar to how you would into an STL map. So you can see here I'm printing out the same way, with the differences obviously when you're iterating a map you're given a pair rather than an employee here. So I passed in p.second, which is exactly what we had before. Again, same thing here. The difference is here I'm using the mutable, I'm getting the mutable pair when I iterate through the map, the multi-index map. Here I'm given an STL standard template library pair because that's what I've keyed on here. Up here is STD. So those are the 3 kind of core data structures, or sorry, 4, including the list, that the Boost libraries go through. But one of the ones I really wanted to check out, because I like to reach for this kind of data structure often when I'm programming, and it's a data structure where, so previously we had we wanted to map the employee's ID to an employee, right? Where in this case it was Bob, something like that. What I often like to reach for is an ID to a list of some kind. In this case I called them aliases, and I just gave them a bunch of nicknames, right? But this allows you to do stuff like in the map, I called it alias map. What you can do is get the ID, and then you can do things like push back, or also like erase, pop back, things like that. So you have this ID that's unique to, in this case I would say maybe an employee, and then I can just keep pushing back a bunch of nicknames and things like that. Another use case would maybe be like in EOS, for example, maybe I take the user's name and then store maybe a list of messages that they've been sent, or maybe a list of messages that they've sent themselves, right? This kind of data structure comes up often. So I wanted to check it out as like an extension of this like little study that I've done here. So we take the exact same mutable pair, we take the integer, and instead we use a list of strings in both cases, right? The difference being, obviously, we have to use this, you know, custom data type, this mutable pair, rather than the STD pair. But other than that, I mean, it works exactly the same as the one above here that we had previously. When I get, well, you can see here I'm creating this list, and I'm keying on ID 1 was Bob, right? I gave him a couple nicknames like Bobby, Bobarama, those kind of things. I did the same thing with Bob 2, Bob 4. These are their quote-unquote aliases, right? And then I insert these into the multi-index. Do the same thing here with the map, exactly the same way. And then down here in the lambdas, I actually had to print out, I have to iterate through the list of strings that I'm given in the pair. But other than that, I mean, it works exactly the same as you would expect. You get the index of the map, and then you can push and pop from that list. Very, very useful data structure. But a little bit cumbersome, as you can see here, when you're dealing with the the multi-index version of the map versus the STD, STL version of the map. So that's pretty much everything for at least the Boost library multi-indexes. As I keep saying, we'll talk about the EOS ones when we start diving more into the smart contracts. One thing I did want to point out is, like, while I was kind of toying around with this map, with this STD map, or sorry, this multi-index version of the map, I found this really, really useful, what they called, what did they call it? Bidirectional map. So you can ensure uniqueness in both directions of the map. I thought that was a very interesting data structure that they came up with. They used it to map Spanish to English phrases here, or sorry, words. So anyway, I'll probably add this little link to the description on both the Udemy and the YouTube video in case you want to check out this interesting data structure. Okay, see you in the next video.